Hi everyone, my name is Choi Wen and my student ID is 0710013. In this video, I'm going to explain the math behind our midterm project. First, every point on this curve must have same period so that they can arrive the bottom at the same time. So it behaves like the simple harmonic motion. So we use the model of SHN to set up our first equation. S is the arc length of the points, which is a function with respect to time t. So now we set up a differential equation. The secondary derivative of S with respect to t is equal to minus omega squared times S. And this one represents the angular acceleration of the point. Then we solve this ODE. Move minus omega times S to the left side, and we solve R1 and R2. We get it's equal to plus omega I and minus omega I. So the general solution to this ODE is C1 times e to the omega it plus C2 times e to the minus omega it, which can be expressed as cosine omega t times C1 plus C2 plus I times sine omega t times C1 plus C2, and use the initial value as when t equal to 0 is equal to S0. We get the solution is S0 cosine omega t. Now we can calculate how long a point takes to arrive at the bottom. We find that when t equals to pi over 2 omega, S will be 0. So the time it takes is nothing to do with where a point starts. With the equation about S and t, next we are going to introduce the Newton's second law to analyze the relation between t and the coordinate of the point. First, we know that the angular acceleration exerted on the point is from gravity. So separate the t on the tangent direction. We get minus omega squared S is equal to minus g sine theta. Then differentiate both sides with respect to theta. And we need to use x and y to replace s. For a small piece of s, we said ds can be viewed as a straight line. So we can separate ds into dx and dy by using ds cosine theta and ds sine theta. Then integrate dx and dy and substitute ds by d theta. According to the previous equation, then we can obtain the parametric curve. X is equal to r times phi plus sine phi, and y equal to r times 1 minus cosine phi, where r is equal to g over 4 times omega squared. X represents the radius, and phi is equal to 2 theta. And we set C1 is equal to 0 and C2 is R. So now we have a complete parametric curve for this picture with the properties radius, angular speed, and period. This curve is called cycloid. It can be drawn as this animation shows. And notice the radius mentioned above is radius of this circle. Along this curve, the points start at different positions will move like this. The more specific explanation about the animation will be given with MATLAB. And that's my presentation about the math behind our midterm project. In the end, let's have a question. Why you shouldn't believe the man in bed? That's because he is lying.